It's 3 a.m. and your LLM agent is stuck. It needs to query the database, check IAM permissions, fetch files from S3, and send a Slack notification. But you've written 4 separate API clients, each with its own error handling and retry logic. Every time you want to add a new data source, you're writing integration code from scratch. This is the API problem. Now imagine a different scenario. Your AI model connects to a single server and instantly discovers what tools are available, what they do, and how to call them, without you writing a line of integration code. MCP isn't replacing APIs. It's solving a problem APIs weren't designed for. APIs let individual services talk to each other. MCP lets AI models reliably discover, call, and act on data across multiple systems without custom integration. Think of it like this. APIs are like having separate instruction manuals for every appliance in your house. You need to learn each one. MCP is like having a universal remote that automatically reads the appliance's capabilities and instantly understands what buttons do what. The key difference? APIs require you to know what you're calling before you call it. You hardcode the endpoint, you hardcode the parameters, and you hope nothing changes. MCP servers publish their capabilities at runtime. When an AI connects, it immediately learns what tools exist and what parameters they accept. It's called stateless tool discovery. A Claude instance connects to an MCP server and instantly has access to query_database, send_email, and fetch_user_permissions. No setup code needed. No manual configuration. But there's more. APIs typically force you to wait for the full response before your code can do anything. You call an endpoint, you wait, you get data back all at once. MCP handles long-running tasks differently. It streams partial results back while the AI decides whether to continue, retry, or branch in a completely different direction. You're searching 10,000 logs? MCP gives you results incrementally. The AI samples after 100 results, decides the filter isn't working, changes strategy, and doesn't waste time waiting for all 10,000. That's streaming responses with sampling. You're not waiting. You're adapting in real time. Now let's talk about context windows. APIs will embed large files or entire datasets in responses, loading your context window and your costs. MCP uses resource references instead. Rather than returning a 50 megabyte CSV, MCP gives the AI a URI and lets it request specific rows or aggregates on demand. Your context stays lean. Your token costs stay down. You're only pulling the data you actually need, when you need it. There's also bidirectional capability negotiation. When an MCP client and server connect, they exchange supported features and protocol versions up front. Breaking changes are detected before execution, not mid-task when everything fails. An older client talks to a newer server, they agree on a compatible feature set, and the client knows not to request experimental features that would break. Let's get concrete. Your support bot needs to access customer records, ticket history, and billing information while streaming results to a web UI in real time. With APIs, you're coordinating 3 separate clients, managing 3 separate timeout behaviors, and waiting for each one to finish before moving to the next. With MCP, one unified server bridges all 3 with consistent error handling and streaming. The bot interrupts or refines queries mid-execution. That's not possible with traditional APIs. A data analyst exploring company metrics, databases, and Jira tickets across 3 systems? APIs force them to tell you which endpoints they need. MCP discovers all available tools and contexts in real time. The analyst doesn't manually list endpoints. They just ask. The analyst doesn't manually list endpoints. They just ask. But here's the reality check. MCP isn't a magic fix for everything. If you have a single, well-documented API and no integration complexity, adding MCP is overhead. If you're integrating with legacy systems that don't support MCP servers, you're still writing custom code. And if your organization doesn't have the infrastructure to run MCP servers reliably, you're just moving the problem, not solving it. MCP shines when you're orchestrating multiple systems at once, and you want your AI to discover and call them without constant code updates. The core insight is this: APIs solve point-to-point communication. MCP solves many-to-many AI-driven orchestration. You're not choosing one over the other. You're using APIs as the transport layer and MCP as the discovery and orchestration layer on top of them. That's where the real power comes from.